Welcome to the JAMB revision question class with chemistry. So we are going to focus on what structure of the atom and electronic what configuration. If you click away, you are going to what lose big time because questions we are going to do under this topic in this video here. These are some of the questions you are going to see live and direct. I never see them anywhere on YouTube. I want to review a lot of secrets that will help you to pass your JAMB chemistry. So if you have phobia or you're thinking of how to work pass chemistry, then you really want to subscribe to the channel, follow each of my video step by step, and consume those contents. So make sure you have your pen, your notebook, and your calculator so I can want to follow through because I'm going to review some secrets that you have never seen before. Let's go into it. So now let's take the first one. This is the type of question you will likely see in your exam. Now, as a matter of fact, this is a question have been repeated over and over and over again. So let me show you here. How many electrons are in the F share of what? Phosphorus 31 out of 15. Now, this is the mass number. This is atomic number. Now, when it comes to electrons here, you really want to understand that it is this one that is being used for writing electronic configuration. Now, in a neutral atom, the proton number and the electron number is the same. So this phosphorus here is having atomic number of 15 and electron numbers of 15. Now, they're asking how many electrons are in the S share. How many electrons are in the S share? Now, before you can understand here, you must understand how to write electronic configuration. And from my research and from observation, now you need to master this one here: 1x, 2x, 2p, 3x, 3p, 4x. You need to master this one here. Now they don't exceed more than this one here. Now when it comes to your JAMB, so this is what I observe. So here we have 1x, 2x, 2p, 3x, 3p, 4x. So we are using only x and only x and p orbital. Now x can accumulate total of 2 electrons, and is that one suborbital. Do you get that? P calculated a total of 6 electrons, electrons, and is that 3 suborbital. So you really want to pay close attention to what I'm going to do here. And we have to call the K, L, M, N, O, P, Q. So here we have the K shell. The K shell is is my first energy level, which is 1. Now, the L share is my L share is my second energy level. My M share is my third energy level. My N share is my fourth energy level. Do you get that? So we have up to 7, but those are not important because these are our focus. These are our focus. So now pay close attention here. You want to know this one here from 1x to 4x because I'm going to use them in writing dynamic configuration of elements in periodic table. So we are in saying that we are focusing on the first 20 elements. I'm going to use x and p orbital. Now x orbital is having one suborbital. P orbital is having 3 suborbital. And you must take note K shell, L shell, M shell, N shell. K shell is the first energy level. L shell is the second energy level. M shell is third energy level. N shell is fourth energy level. So you have to copy this one down because you are going to make use of it in this question. So let me write this place. So now, the first thing you want to do here is write electronic configuration for phosphorus. Do that. So I want to use and I'm going to use 15 electrons. Remember I told you that in a neutral atom, the proton number and the electron number are the same, or the atomic number. Proton number and atomic number, they are the same. Hope you understand. So in a neutral atom, proton number and electron number are what equal because it does not have what charges. Now when we get to the one that contains charges, now what positive charge or negative charge, I want to explain that to you. In the sense that you want to write electron configuration for this element what 15 what electrons. So remember I told you that I want to use 1x, 2x, 2p, 3x, 3 what p, 4 what x. So now let's look at what I want to use. I want to follow what this blueprint here. Now, remember, S can only have an electron, 2 electrons, right? So you have to get 1x2. Now, if you put 2 here, it means that out of the 15 electrons, you have used 2 electrons. How many electrons that will be left? 15 minus 2 is what? Is 13. Is what? 13. So let me go to the other one. 2x2. Do that. Now here, there is no way I can put 2 here. Please understand here. Do you know the reason why? Because S can accommodate only what? 2 electrons, either 1 or what? 2. So anything more than 2, there's no way. So you have to what? Remove say and put what? 2. Do you get that? So it means that out of what the 50 electrons, I've used 4 what? Electrons. Let's continue here. Here we have 2p. Remember, P can accommodate how many electrons? 6 electrons. Do you get that? So if I should put 6 here, means that out of the what 15 electrons, I've used 10 electrons already. Do you understand? Left how many? 5. Next thing is what? 3x. S can accommodate how many electrons? 2 electrons. So I'm going to put 2 here. Do you understand? The next one is what? 3p. Now, the number of electrons left is what is 3. So the 2 will just go to this other point here. Do you understand? Now, that was not the question. This is just an electronic configuration for what? Phosphorus. Do you get that? Now, but they say how many electrons are in the L share? Remember that KLMN, right? So K is what is the first energy level. First K share is what? First energy level. That is my number 1. Do you get that? My L share is what? My second energy level. Do you get that? So that talk about L share, which was second energy level. My second energy level is what is 2. And here we have 2x, 2p. Do you get that? They're asking how many what? How many electrons are in the L share? What I'm going to do here, I'm going to what? Sum these 2 electrons that were in second energy level. So it will be 2 plus 6, which is what? Is 8. Which is what? 8. So in the sense that the answer is what? Is C. Do you get that? Now, there are a lot of questions you can use this one to answer, but now let's stop here based on what this question. Now let's look at what question 2. Let's move over to what the next question. Say, how many electrons will oxygen need to gain in order to attain a stable state? They are talking about the combining power of what? Oxygen. Now, when it comes to combining power of an element means that the numbers of electrons it needs to what? Give out or gain in order to what? Obtain what is stable configuration or stable what? Or stable state. Now, stable state means what? The noble gas state. Now, we have recorded the noble gases. We have recorded the helium, the what? The neon, the argon. We also have some other one here. Now, let's focus on this for here. Now, this one, the only configuration is what? Is 2. Here we have 2 what? 8. Here we have 2, 8, 8. Now, this one is called old electronic configuration. It suits this question here. Do you get that? So elements want to attain these states. Now, the electron number of helium is what is 2. This one is what is 10. This one is what is 18. Do you get that? Now look at something. This is called the old electronic configuration. So every atom or element want to have what the stable configuration here. So in the sense that they want to have what 8 electrons in their atmosphere. So that is why their commanding power their commanding power they can either what lose or gain. Do you get that? In order to attain this stable configuration. So when we talk about the how many electrons will also need to gain in order to obtain the stable configuration. In the sense that what I'm saying here, how many electrons how many electrons will oxygen gain in order to obtain the octet configuration? Do you get that? So instead, I will look at oxygen. Oxygen is what the electron number is what is 8. So if you should write the old electron configuration, which is what 2 and what and 6. You get that? That is 2 electrons in the what first shell, 6 electrons in the what second what shell. Do you get that? Now oxygen want to behave like what neon. Do you get that? So here is 6. That you need to what gain electron, you need to what to gain to have it. Do you get that? Because if you want to behave like what neon, now electron is what is losing here. Like we don't have enough electron here. So how many electron does it need to have? How many electron does it need to gain in order to have it? It's 2. Do you get that? So that is the combining power of oxygen here is what is 2 is what is that you need to what gain 2 electron. So if you should gain 2 electron here, it's going to have 2 and what 8. Do you get that? So that's going to be what O2 what minus equal. Remember when non-metal gain electron, they become what a negative what charge. We call what anion. Do you get that? So the combining power of oxygen here is what is 2. That is that what gain 2 electron to obtain what the stable state. So what is the answer? The answer is what is A. Just let's look at what on that question. So let's look at what the third question. If the electron configuration of an element is 1s2, 2s2, 2p5, how many electrons are in the world are there? Now I want to comment on your on the comment section. How many electrons are here? How many electrons are here? So comment it on the what comment section. How many electrons do we have at this point? So also comment your answer. What will be the answer here? Comment it here. I want to hear from you. Yes. So now here we have 2 electrons, 5 electrons, making what 4 plus 5, which is what 9. So which element in the periodic table have what 9 as what electron number? Comment your answer at the comment section. So now I want to get what the unpaired electrons, electrons. So I'm going to write some arts. When I write some here, and I want to have 1x2, 2x2, 2p5. Now I'm going to focus on the last one. We got 2p5. So I want to focus on what on p. Do that. I want to focus on what on p. Remember that p have 3 suborbitals. So if you draw the orbital diagram here, like this. This is that. So p is going to be -1, 0, and +1. Now in my future video, I'm going to talk about quantum numbers. So if you're not subscribed to the channel, please endeavor what you subscribe to the channel so that you're not going to miss out my future video, because I want to do more. So I want to do gas, I want to do organic chemistry, I want to do so many questions, like revision questions in what different topics. So you don't want to miss out. If this video is helpful, please always leave at the comment section that this video is helpful. It goes a long way to tell me that you that is watching the video on the other side is actually getting tons of value. Please don't be like others that will just watch the video and just click away like that. Please always leave a like, because that is how it shows that this video, more people are interested in this video, so it can spread to other persons. That is the only thing. You're not paying for this video here. You're not giving me any money. The only thing I want for you to watch, like this video and share the video. Do that. So the sacrifice I'm putting on this video here will be what counted. Please do that for me. So now P is having how many suborbital? 3 suborbital, -1, 0, +1. Don't worry if you don't understand what is -1, 0, +1. When I talk about quantum number in details, you understand this better. So for now, let's remove it. Now we want to what 5 electrons, because how many electrons do we have here? 5. Now according to Ohm's rule state that when filling electrons into what suborbitals, electron must spin up before what spinning down. Electron must spin up before what spinning down. So how many electrons do you have? 5 electrons. So now let's spin them up. After we spin them up, now come back. So you have 1, 2, 3, right? So when only they spin up, there's a used how many electrons? 3 electrons. So out of 5 electrons, how many do you have left? 2. So 4 and what? 5. Do that. So this is how to do it. So from here now you can now what get what your numbers of paired and what and unpaired. Now here we have two paired electrons. Two paired electrons are what? One unpaired what? Electron. The question is not paired up. This are what paired up, but it's not paired up. So here we have two paired electrons, one unpaired. Now let's look at the question again. Say if the electron configuration of the element is this, how many unpaired electrons are there? So because here we have two paired and one paired, we're talking about what? The unpaired. So how many unpaired electrons do we have here? Is what? One, which is what? A. Hope you understand. Please, if you understand, say understood at the comment section and give it a like. Let's move to what? To the next question. So let's look at what? Question 4. They say, what is the maximum numbers of electrons in the what? 2p subshell. Now look at the option here. Now remember here we have x and what? P, s, p, d, f. So s, p, d, d what? F. Do that. There are the 4 suborbitals what in chemistry. Now here we have 2 electrons. That is s can commute of what? How many electrons? 2 electrons. Now here is what? Is 6 what? Electrons. 6 electrons. D is what? Is what? 10 what? Electrons. F is what? Is 14 what? Electrons. Right here. So it means that the maximum numbers of electrons in which P calculates is what? Is 6. So let's look at what the answer is. The answer is what? Is C. Do you get that? The answer is what? Is 6, because I talking about the maximum numbers of electrons in which what? 2p. Don't look at the 2, look at what the p. Do you get that? So that is the answer, P. So let's look at what? Question 5. An element which has atomic number of 13 is likely to have a combining power of. So what is the combining power of an element with what? Electron number of what? Or atomic number of what? 13. You get? So remember, in initial atom, the electron number is also listed as atomic what? Number. Do you get that? So when we talk about 13, now when we talk about the combining power, I mean that the numbers of electrons in show what an element will lose or gain in order to what? Gain the octet or achieve the octet electron. Now we are talking about 13. So let's write the old electron what configuration. Remember, we have done that before, right? So the first shell will take 2 electrons, right? The second shell one will take what? 8 electrons, right? Remember, we have 13. So 2 plus 8 is what? Is 10. Let's have 3 left. So we have 3. So you say that now this atomic electron will it lose it or gain or add to it in order to achieve the octet electron? Now it's very easy here. Now for this guy to attain the octet electron, it has to what? Give out what? 3 electrons. Then this atomic electron, these 3 atomic electrons, you have to what? To lose it. So it means that the combining power of this element here, or with that of element with this atomic number or electron number, you have to go 3. 3 because the combining power means what? The numbers of electron and element what to lose or gain in order to achieve the octet. To achieve what? The octet. So this guy, for it to achieve the octet, that is 8 electrons, that will lose the what? The outermost what? Electron. So that will lose this one here. So the commanding power of this element is what? Is 3. So what is the option here? The option is what? D. You get. Let me to the next one. Our question 6, but you be the one to do it for me. I'm not going to solve this one here. I believe with what we have been doing so far, I should be able to answer this question. So, how many unpaired electrons are there in the electron configuration of an element with atomic number 8? So I believe I've done something like before. So you want to what? Leave your answer at the comment section. Question 6, is it A, B, C, or D? So leave your answer at the comment section. I will check that. So let's move to the next question. So let's look at what? Question 7. In the aluminium ion, look at the aluminium ion here. The mass and the electron number are what? Respectively. So let's look at it very well. I've done several videos on this topic. I will leave the link at the description. So probably by the end of this video, you want to go check out that video for full understanding in case you are not familiar with this topic. However, I'm going to explain briefly for you so I can switch our answer this question here. So when talking about aluminium here, aluminium is what? 3 plus. So 27 and what? 13. Remember I told you that in a neutral atom, proton number and electron number are the same, right? So even my mass number is 27, my proton number is what? 13. Do you get that? So mass number mass number is equals to what? 27. So proton number. Now, proton number and atomic number are what? They're the same. The numbers of what proton in an atom is known as what? The what? Atomic what number. Do you get that? So it's what? It's 13. Now, in case they ask you what is the neutron number? Neutron number. Neutron number. Neutron what number? Neutron number is what? When you subtract the proton number from what? Mass number. So 27 minus what? 13 is 14. Do you get that? Now, how do I get my electron number? Do you get that? Now, when it comes to what? Ions, now you can either what? Gain or lose electron. So now whenever you see an ion with what? Positive charge, it means that it can what? Lose electron. Do you get that? So this one, whenever I see 3 plus, it means that it can what? Lose 3 electrons. So the proton number and the electron number are not the same again. Now, if you should subtract 3 from here, 13 minus 3 is 10. So electron number is what? Is 10. Why? Because it has what? Lost 3 electrons. So you can either what? Atom can either what? Lose or gain. So whenever I see where a cation means what? A positive charge. It means that it has what? Lose electron. So you subtract this one from this one here to get the electron number. Now, however, the question does not ask of a proton number or a neutron number, but it's very important to know. So you have my mass number is what? Is 27, my electron number is what? Is 10. Now let's see the option here. It's not this one here, it's not this, but what is this guy? So 27 and what? 10. That is what answer. Level to what? Question 8. So question 8. How many principal electron share has an atom whose electron configuration is 1s2, 2s2, 2p6, 3x1? Now I say how many principal electron share? They're talking about what? Share. They're talking about share. Do you get that? Share means what? Remember, we have the first share, second share, what, and third share, fourth, fifth, sixth, and what, 7, right? So 1, 2, and 3. That is what? 3 share. That is going to be 1, 2, and 3. Remember, this one is what? This one is what? K share, L share, what? N. That means what? 1, 2, and 3. Do that. So the option, the answer is what? Is 3. 3 share. First, second, and third. Do that. Then talk about what? The orbital. Here we have X and what? P orbital. Orbital is what? Is 2, but the share is what? Is 3. Do you get that? So that is what answer. The answer is what? Is C. So let's look at what this question. You see that the electric configuration of what? Magnesium ion is. Do that. So now we want to write the electric configuration for magnesium ion. Normally, magnesium, the atomic number is what? Is 12, right? So that the electron number here is what? Is 12. You get. So if you want to write the electric configuration, it's going to be 1s2, 2x2, 2p6. Do that. You follow what that pattern I've given to you. 1s2, 2s2, 2p6, right? How many electrons have I used here? I've used how many electrons? I've used 10 electrons. Left how many electrons? 2 electrons. So let me go 3x2. Normally, you know what? In magnesium metal, there is a neutral magnesium. There is an atomic number of 12. This is the what? Electronic what? Configuration. I get 1s2, 2s2, 2p6, 3s2. However, they say magnesium ion. That is, remember, when magnesium lose electron, or when magnesium want to attain the octet electron, it's going to lose 2 electron. Now this is just like here we have 2, 8, 2. This is called old electron configuration. So the new configuration. In your secondary school, this is what you have been taught. But in reality, this is what you're going to make use of. You get it corresponds to this other one here. So it says that for magnesium to obtain the octet, that would lose the what? The outermost electron, which is 2. So when magnesium lose what? The outermost electron, you're going to go 2 positive. So the electron number is no longer what? 12 again. You got that have reduced to what? To 10. It is saying that it has what lost this one here. So we're going to do what 1x2, 2x2, 2 p what 6, which corresponds to what 2 8. So this is what is the electrical configuration of what magnesium 2 plus. Now let's check what option. Is it this one here? Of course, it's not this one here. Is it this one? No. Is it this one? Yes, it's this guy. This guy is what? Is this guy here? Is what? C. C is what? Answer. Do you understand? Please, if you understand, please say understood. If you are following, please try to say you are following and you are getting tons of value. Please, I will appreciate it more when you what like and subscribe and what comment. It's very important. If you have anybody that wants this video or that also writing JAMB chemistry this upcoming exam, please try to share this video to that person. It's very important. So I want to look at what one more question before we end this video. So let's look at what the last question. Now let's say that here we have this diagram here. Say the diagram above will present the what electron sub level of. So which elements have this diagram here? You got orbital diagram. Now the first one to do here is to calculate the total numbers of what of the electron. Here we have 2, here we have 2, here we have 4. So 4 plus 4 is what? 4 plus 4 is what? Is 8. Okay. So now to say which element in the periodic table have electron number of what of 8 or atomic number of what of 8? The answer is what? Is oxygen. The answer is what? Is oxygen. You got so what they're asking here, which element in the periodic table have this diagram? So you want to do is what? Calculate the total numbers of the electron here, and ask yourself which element in the periodic table have the what that atomic number or electron number. So we're talking about a neutral atom, a neutral what atom. That is a neutral atom that is cannot what lost or what gain electron. Remember, in a neutral atom, the proton number is also what the electron number. So this 8 is what is either the electron number or the atomic number. And oxygen is the one that is having what 8. The position of what of so the answer is what is oxygen. So we are going to end our video here. Thanks for staying to the end of this class. So we also have some other videos here. Like if you want to learn about gas laws, Charles law, Boyle's law, and the rest, then watch this video for that.